So each lesson in this unit, we're basically going to be going over more shapes to sort of add to your knowledge so that when you're asked to prove things, you know the properties and what you have to look for. So now we're going to look at rectangles and rhombi, so rhombuses. So these are both parallelograms, so they have all of the same characteristics that we talked about in the previous lesson. So we know that they have to have opposite sides, are parallel and congruent, opposite angles are congruent, and consecutive angles are supplementary. So those are the big ones that we talked about in the previous. We also know that diagonals bisect each other. So these are all true for both parallelograms and now also rectangles and rhombus. Now what makes a rectangle unique is that it adds two things. It adds that all of the angles are right angles, and the diagonals are congruent. So the diagonals themselves, right? If we're going to label this as A, B, C, D, we know that AC is also congruent to BD when it is a rectangle. This is not true for just a parallelogram. Now a rhombus, right? This is unique because for our rhombus, we'll call it D, E, F, and G. This is a parallelogram. So normally we would just have opposite sides are congruent. In a rhombus, all four sides are congruent. Additionally, the diagonals are still bisecting each other, but in this case, they are also perpendicular lines, so they form right angles, and they also bisect each angle that they hit. So we form, so if you zoom in, right, when we see, so GE is your diagonal, GE bisects angle G and angle E. So there are two angles that are congruent in both of these, and the same thing goes for DF as well. So now we're going to use these facts to figure out some of our missing things. So first we're going to be dealing with a rectangle. So if you want to mark, so you first know that all of your angles are going to be 90 degrees, right? So there's really not much for solving angles because you already know they're all 90. So if we know that PQ is 24, then opposite has to be congruent because it is still a parallelogram. So SR is going to be 24. If PS is 10, then QR is going to be 10 as well. So now they're asking us for the diagonal. So the reason why I put this over here is because if you look at a rectangle is actually made up of two right triangles now. So you can use the Pythagorean theorem to solve for your diagonal using a squared plus b squared is equal to c squared. Right? So in your calculator, what you would do is 10 squared plus 24 squared. So in this case, we get 676. Now you're going to do the square root of 676, and we get 26. So SQ is 26, and it's also true that we know that the diagonals are congruent. So then PR is also 26. And now it's asking for QT. So QT is half of your diagonal. And we know that because it's a parallelogram, the diagonals bisect each other. So this is just going to be half of our diagonal, which is going to give me half of 26, which is 13. So now I'm going to do the same thing for the next one. So in this case, they gave us AB is going to be 27 because CD is 27. Since AE is 15, you know that EC is also 15 because the diagonals bisect each other. Then you also know that these have to be the same as well because the diagonals are also congruent. So let's see what I can fill in. So if we're talking about AC, AC is 30. BD is also 30 because the diagonals are congruent. BE is 15. Oh, I wrote it in the wrong spot. So AB is 27, AC is 30. And now I want to know what BC is. So again, you're going to need to use the Pythagorean theorem. So if we highlight our triangle, except in this case, we have that A is 27, B we don't know, and C is 30. So set up the Pythagorean theorem. So we have 27 squared plus x squared is equal to 30 squared. So now in your calculator, you're going to do 30 squared minus, it was 27, right? Yeah, 27 squared, because when you're solving for a leg, you're going to subtract. And now you're going to do the square root of 171, which is 3 radical 19. So this is using the properties of a rectangle. Now we can do some with a rhombus. So again, a rhombus has 4 congruent sides, perpendicular diagonals, and the diagonals bisect the angles. So if JK is 12, then so are all of the sides of this rhombus because all the sides have to be congruent. If JN is 7, then I know that NL is also 7 because the diagonals still bisect. So I know that JL is going to be 14. I don't know what MK is yet because the diagonals are not congruent in a rhombus. I do know that the diagonals are perpendicular. This is where Pythagorean theorem is going to come back. A squared plus B squared is equal to C squared. A is 7. Don't know what B is. So we're going to do 12 squared minus 7 squared. We get 95. Square root of 95 is, we're going to round that to 9.7. So that is the measurement of NK. So MK is going to be 2 times 9.7, which gives me 19.4. So MK is 19.4. MN would be the same as what we found for NK, and JM is 12. So now let's look again. EF is one of our sides, so that's 23. So all of your sides have to be equal to 23. So let's see, EG, DG. So GF is equal to 23 because it's a side. We're also given that DF is 40. So each of these little pieces is 20 because they get cut in half. So HF is equal to 20. We want to know what GH and GE are. So GH is right here. So if we look at this, this forms a right triangle. Same thing as before. 20 squared plus B squared is equal to 23 squared. So 23 3 squared minus 20 squared is 129. Square root of 129, we'll say it's 11.4. So then GE is going to be 22.8 because it is double of your half. So those are the new properties for both the rectangle and the rhombus. You should use that to do some practice problems and make sure that you remember that it includes everything from parallelograms, but also those several unique characteristics.